Bang per buck. Produced for Econ 410. This is Michelle Sheran-Andrews. To get the most out of this help sheet, take the time to remember these concepts before reading the help sheet. The help sheet presumes you've mastered them. For your convenience, this list and the others you'll see in the video are posted on Sakai in the help sheet folder. Now you're ready to read and study the help sheet itself. The purpose of the help sheet is to organize and synthesize key concepts. The help sheet can be a great reference for you, but it's meant to do much more. I'll explain how in this video. After reading the help sheet, spend time on each of these points. This list represents what you should directly take away from the help sheet. Please know that there can be a big difference between understanding something you read and communicating it yourself. A highly effective way to assess your understanding is to actually try expressing these concepts out loud. Put the concepts in your own words and pretend you're teaching them to someone else. Question and pick apart your understanding. Now we'll apply these concepts with the following practice problem. This is only one example of the kind of problem you may see corresponding to this help sheet. There will be other problems along the way, but this one will get us started. Let's work through this practice problem. To determine whether Bill is maximizing his utility, one approach we can take is to calculate and compare his marginal rate of substitution with his marginal rate of transformation. The marginal rate of substitution, or MRS, is a ratio of marginal utilities. Let's say we place video cameras on the x-axis and deflated footballs on the y. That means the MRS is marginal utility of video cameras divided by the marginal utility of deflated footballs. In this problem, marginal utility of video cameras is 6 and of deflated footballs is 1, and so we have an MRS that equals 6. Similarly, the marginal rate of transformation is a ratio of prices. Given that I chose to place video cameras on the x-axis, the numerator here is the price of video cameras. Deflated footballs is on the y-axis, and so its price is in the denominator. In this problem, that gives us a value of 124 divided by 26, which is approximately 4.77. So we see that Bill is not maximizing his utility. To do so, his MRS would have to equal his MRT, but in this case, the MRS is greater than the MRT. Let's see that on the graph so we can know what Bill should do. Bill's current consumption bundle, or the one he's currently considering, has 5 video cameras in it and 11 deflated footballs. At this bundle, we know that his indifference curve is not tangent to his budget line because the slope of the indifference curve is more than the slope of the budget line. To show the slope of the indifference curve being greater than the slope of the budget line, we need to add an indifference curve that's steeper than the budget line at this bundle. So here I've shown that the current bundle that Bill is planning to consume is one on the budget line at which the indifference curve is steeper than the line, and so the slope of the indifference curve, called the MRS, is bigger than the slope of the line, called the MRT. Clearly, that's not the highest indifference curve. There's a higher indifference curve that Bill can reach. In fact, the highest indifference curve would be what I have labeled as IC2. His utility maximizing bundle happens at a value for video cameras that's bigger than 5 and a value for deflated footballs that's less than 11. So we're telling Bill, yeah, you're not maximizing your utility. You should consume more video cameras and fewer deflated footballs. Let me explain why this also makes sense. Think about what these numbers up here mean. both are rates of trade, both are slopes. Both as slopes represent a rise over a run. The rise being the change in deflated footballs, and the run being the change in video cameras. Both the MRS and the MRT are slopes, and as such, both represent a rise over a run. So what does the 6 mean? I go back to that. What does an MRS of 6 actually mean? Well, what it means is that according to Bill's preferences, if you give him one more video camera, you can take away 6 deflated footballs and he'll be just as well off as he was before. To get one video camera, he's willing to give up to 6 deflated footballs. Now consider this number, the MRT of 4.77. Also a rise over a run. 4.77 is how many deflated footballs he can afford to buy if he gives up one video camera. Or if he buys one more video camera, he'll have to give up 4.77 deflated footballs. So the rate at which Bill values video cameras is more than how the market values video cameras. Bill says, I'm willing to give up 6 deflated footballs to get one video camera. And the market says, well, you only have to give up 4.77. So there's a chance for Bill to arbitrage here and be better off. And that's exactly what's happening. By moving towards video cameras and away from deflated footballs, he is going to move to a higher indifference curve. And that's because of the principle of diminishing marginal utility. As he moves towards the video cameras, as he consumes more and more video cameras, the marginal utility of video cameras should go down if, in fact, goods display the principle of diminishing marginal utility. And as he moves away from those deflated footballs, the marginal utility of a deflated football should go up. So we have this initial imbalance, but as the marginal utility of video cameras goes down and as the marginal utility of deflated footballs goes up, this MRS should fall until the MRS equals 4.77. Now let me show you another way of approaching this problem. This way is going to calculate the ratio of marginal utility to price. We're going to calculate the marginal utility per dollar spent on each good. Let me explain. The problem tells us that for Bill, the marginal utility of a video camera is 6, and the price of a video camera is $124. So, if Bill spends $124 on a video camera, his total utility will go up by 6 utils. If we simplify this number, we get something ugly, but we get a number, and that number is 0.05. That means for every $1, there's the buck, for every buck that Bill puts towards a video camera, the bang, the reward is 0.05 additional utils of happiness. Now, compare that to the bang per buck he gets from a deflated football. The marginal utility of a deflated football is 1, and the price of a deflated football is 26. So if he puts $26 towards a deflated football, what he gets is 1 additional util of happiness. Again, let's make this a decimal, so that would be 0.04. For every $1, for every buck that he puts towards a deflated football, the bang, the reward, is 0.04 additional utils. We see here that his bang per buck is higher if the buck is spent on video cameras, which again is why we're telling Bill, yeah, you should consume more video cameras and you should consume fewer deflated footballs. And as you do so, as the consumption of video cameras goes up, the marginal utility should fall, making this bang per buck fall. And as the consumption of deflated footballs goes down, marginal utility of deflated footballs should go up, increasing this side, this bang per buck, until they're equal. Now, this approach is nothing different really than what I showed you at first because these two are connected. And that's what I'm showing you here. You can start by comparing the MRS and the MRT, but then by making one algebraic move, by multiplying by this ratio, you reveal that the comparison of MRS and MRT is the same as the comparison of bang per bucks. Still with me? Do you feel you have a solid understanding of the material and the practice problem? If not, go back and repeat the remembering, understanding, and applying steps. But if so, know that you're not done. You've not yet mastered the concepts. You've just taken the first steps, but there's still work to be done. Strive for a higher order level of understanding. To do this, now turn to analyzing and evaluating and creating. Again, these lists are posted on Sakai, so take the time to complete them. You will have the opportunity during recitations to share and compare your answers with those of your classmates. And this concludes the video. As always, ask for help whenever you need it.